Hello everyone, I am Tarun VG, a student of VIT Chennai. Today I am going to explain you about our MPMC project that me and my two other college mates did. The project is Automatic Irrigation System using 8051 microcontroller. This project is designed to automatically supply water to plants depending on the soil moisture level using a simple cost-effective microcontroller and an LCD display, a soil sensor and a pump which operates the water flow. The main idea of this project is to reduce manual effort and avoid water wastage. Our system automatically senses when the soil is dry and turns on the pump, and then it also detects when the soil is wet to turn off the pump so that no water is wasted. In this entire video, me and my college mates will explain you about our project, how it works, the explanation of our code, the circuit diagram, everything about our project.
So this is our complete setup of our project, automation engineering system using 8051 microcontroller. I'll start by saying explaining you the components of this project, and then I will explain you the workflow of this project. Starting is this two probes attached with this sensor. This is the whole soil moisture sensor used in this project. It has an LM324 comparator and a small potentiometer. I'll get to it later. And then this small thing, this is a relay. This controls the fan. This is used to control the fan. Gets the signal from the microcontroller, which in turn gets the signal from here. Now this gives the signal to the microcontroller. That is, when the soil is dry, it will send a high signal, and when the soil is low, it will send a low signal. When the soil is wet, it will send a low signal to the microcontroller, which in turn sends to this blue thing, the relay module, which in turn activates the pump. Since I can't show you a pump, I used an example of a fan here. At the end of the video, I will show you how this entire project works. This thing here, blue thing here, is a buck converter or something, a converter voltage regulator basically. It takes the input from the 220 volt source and it powers it down to a 5 volt signal, which is used to power the microcontroller. This is a LED screen. It will show you when the motor is on or when the motor is off. This is a USB to serial something converter. This will convert on your computer the program to the microcontroller's TTL, USB to TTL converter. This is basically a converter, and this small thing is a potentiometer, which will help stabilize the system from the back EMF. Now I'll explain you how the flow of this project works. Basically, this sensor is placed in a soil. If the soil is dry, it will send signal as high, and if the soil is wet, it will send you a signal as low. The signal is sent to this thing has a potentiometer inside it. It already has a reference signal. It references the signal sent by this two probes with its reference signal, analog signal, and then it sends a digital signal to the microcontroller, which in turn sends a signal to the relay, which powers the fan or pump as in a normal system. As you can see here, there are only 3 pins connected, but there are 4 pins in the system. So why there are only 3 pins connected is that as the 8051 microcontroller does not have an ADC, the A0 port is not used here. Only the 3 pins are used. And when the motor turns on, the LCD will display motor on, and when the motor is turned off, the LCD will display motor off. So this is the basic working system of our entire project.
So looking at the connections of circuit diagram of the automatic irrigation system, we are using 8051 microcontroller, which is an 8-bit microcontroller. It controls all the operations based on the input from soil moisture sensor, which is over here, and it gives output through the LCD display and the relay module. Now the power supply is regulated via a 5 volt DC supply, which powers the microcontroller and all other components in this given circuit, and also the soil moisture sensor. It has a 12 megahertz crystal oscillator on pins 18 and 19 of the 8051, and few other capacitors, and emergency reset button at pin 9. The LCD module is a 16 by 2 LCD module, LM016L. This LCD module shows the moisture level and the system status, whether the motor is on or off. The LCD's data pins that are D0 to D7 are connected in the IO port 2 of the microcontroller from P2.0 to P2.7, and the LCD control pins are like RS, RW and EN are connected to the port 3, input output port 3, P3.0, P3.1 and P3.2 respectively. So RS on P3.0, RW on P3.1 and EN on P3.2. So EN enables the LCD to latch the data, and the soil moisture sensor. It is an analog type sensor. It detects the moisture from the soil, and this sensor's output is received by the microcontroller on port 1, P1.0, and when the soil is dry, the sensor sends a high signal 1, and when the soil is wet, it sends a low logic signal. Now, based on this signal, the microcontroller decides whether the water pump needs to be turned on or off, and the relay module, which is basically a NPN transistor, this acts as a switch based on from the output of soil moisture sensor. It turns the motor on or off, and to reduce the damage by the back EMF generated by this NPN transistor, we are using a diode, IN400 diode, which gives back EMF protection. So the transistor's base is connected to P1.0, P1.7 of the microcontroller, and these are the overall connections of the microcontroller which is being used for this purpose.
I'm CMT Sushindran, and this video I am going to explain a complete assembly language program for a soil irrigation system using 8051 microcontroller. We'll go line by line through the code and understand how it automatically controls the motor based on the soil moisture level, and also displays the motor status on the LCD. Our project uses 8051 microcontroller, a 16x2 LCD display, a soil moisture sensor, and a motor or a pump that turns on and off based on the soil condition. The sensor gives a logic signal. If the soil is dry, it outputs high, and if the soil is wet, it outputs low. Let's get started. ORG0000H. This line means that our program starts at the memory address 0000H, which is a standard starting point for 8051 programs. Now we define symbolic names for the important pins using the equate directive. RS equate P1.0, RW equate P1.1, EN equate P1.2, RE equate P2.0, and SE equate P3.0. RS, RW and EN are the LCD control pins connected to port 1. RS decides whether the resending data or command. RW set to 0 for write mode. EN enable used to latch data to LCD. RE is connected to the port 2 used to control the motor, and SE is connected to port 3 used as sensor input from the soil moisture sensor. The main program starts here. Main. Move P1, hashtag 00H and move P2, hashtag 00H. Set PSE. Here we clear ports 1 and 2, initialize them to 0. Then we set bit SE to make it work as an input pin for the sensor. Next, call LCD underscore INIT. This calls the LCD initialization routine to prepare the LCD for the display. Now we show the title of a project. Move DPTR, MSG1 call LCD string, move A, hashtag 0C0H call LCD underscore command, move DPTR hashtag message2 call LCD string. Explanation. Now coming to explanation part of it. DPTR points to the memory location of our message. LCD string sends the character one by one to the LCD. The command 0C0H moves the cursor to the second line of the LCD. The first line shows soil irrigation and the second line shows system. Then we call the delay routines A call delay, A call delay. These provide enough time for the user to read the message on the LCD before moving to the main loop. Now coming to the main loop. Main loop. The program continuously monitors the sensor pin SC. JBSC motor on means jump if bit SC is set, that is if sensor detects soil dry. If SC is not set, soil is wet. The LCD shows motor off. The motor is turned off by clearing RE. Small delay is added. Then the loop repeats. If the soil is dry, the program jumps to the next section. Motor on, move A #01H, call LCD command, move DPTR #message on, call LCD string, set bit RE, call delay, short jump, main loop. Now coming to the explanation of it. LCD displays motor on. Motor control pin RE is set high, which turns on the motor. Then it delays for a while and jumps back to the main loop to continue checking the sensor. LCD subroutines. Now let's see how the LCD works internally. LCD INT. LCD INIT. A call delay, move A, #02H. A call LCD command, move A, #28H. A call LCD command, move A, #0CH. A call LCD command, move A, #0CH. A call LCD command, move A, #06H. And move A, #01H. A call LCD command, move A, #80H. A call LCD command ret. This sequence sets up the LCD in 4-bit mode, 2 lines and 5:7 font, and clears the screen. Each move A, hashtag sends a command code to the LCD through LCD command. Now coming to the LCD command code. LCD command move P1, A, clear RS, clear RW, set BEN, A call delay, clear EN and ret. This sends the command to the LCD. RS equal to 0 means command mode. EN goes high, briefly to the latch the command. Now coming to the LCD character. LCD underscore character move P1, A, set BRS, clear RW, set BEN, A call delay, clear EN RET. Explanation. Coming to the explanation of it. This sends the data to the LCD. RS equal to 1 means data mode. Characters are displayed one by one. LCD string. Now coming to the LCD string code. LCD string clear A, move C, A, at A plus DPTR, JZ done, A call LCD underscore character, INC DPTR, SJMP LCD underscore string and ret. This reads characters from memory one by one from the address in DPTR and sends them to the LCD using LCD character. This keeps printing until it finds a 0, which marks the end of the message. Now coming to the delay code. Delay. Move R6, #255, DL1. Move R7, #255 and DL2. Decrement jump not 0, R7, DL2. Decrement jump not 0, R6, DL1 and return. This creates a time delay using nested loop with registers R6 and R7. It slows down operations useful for LCD timing and motor control stability. Message defines. At the end of the program, MSG1 DB soil irrigation, 0, MSG2 DB system, 0, MSG underscore on DB motor on, 0, MSG underscore off DB motor of 0 end. These are the string constants stored in the memory. Each message ends with a 0, So LCD underscore string knows when to stop printing. The program ends with an end. So to summarize, The LCD is an initialized and displays the system title. The sensor input pin SC continuously checks the soil moisture. If the soil is dry, the motor turns on and LCD shows motor on. If the soil is wet, motor turns off and LCD shows motor off. The loop runs continuously, forming a complete automatic irrigation system. Now let's look at the final output in key. You can see that the port 1 is connected to the LCD, which displays soil irrigation system. At the start, P3.0 is high, meaning the soil is wet. As a result, P2.0 is steady. This shows that the motor is off. Now I'll simulate a dry soil condition by unticking P3.0, which makes it low. Immediately, P2.0 starts toggling continuously. This represents the motor running to supply water to the soil. Once the soil becomes wet again, I'll tick P3 back to high. Now P2.0 stops toggling and stays constant, meaning the motor is turned off automatically. So this clearly demonstrates that our automatic soil irrigation system detects soil dryness and automatically switches the motor on, and when the soil is wet, it switches the motor off. This verifies that our system is working perfectly as designed. Thank you for watching. Now I will show you how our entire project actually works. I will simulate you how the project working. When the supply is switched on, you can see the soil irrigation system is displayed on it. Now, since the sensor does not sense anything, the motor is on, basically meaning that when you place it in a dry soil, the motor turns on and waters the soil. Now, since I don't actually have a farm or wet soil in my house, I'm going to simulate you the basic idea, the concept on which the motor turns on and turns off. If you place these two electrodes in a wet soil, these electrodes pass current to the sensor, meaning that the soil is wet and it's time to turn off the motor. I will now show you how it basically works using an iron rod. I'm keeping this iron rod here. Since the iron rod passes current through the sensors, the motor is turned off. This is how our project basically works. Thank you for watching the entire video, and I hope you understood how our project automatic irrigation system using 8051 microcontroller works.